Well, thank you, Suzanne. It's a pleasure to talk with you today about DOE EPSCoR. As you'll hear, NSF is different from NASA, is different from DOE. And so what we're trying to do is to do a little contrasting of what's going on in these various agencies. One of the things I thought I would do today, because DOE is typically funding 3-year awards. We are in the middle of a second 3-year award on one topic, and it may or may not be a while before another RFP is issued. It may be this year, it may be next year. I thought it would be useful to talk about how DOE reviews awards using one that we just put in, and we've got very close to funding. And it was what I thought I would do is talk about what are the little tweaks that might have led to a positive result instead of a negative result. And I do this mostly because the proposal we put in was excellent, and it was done in a very short period of time. So this is very, very competitive, and you'll see that it really is quite close to being successful. And I thought it would be useful to go through that, particularly among friends, and look at what kinds of things you need to do at the national level to get one of these awards made. It's saying that same thing. I wanted to mention that the program manager for DOE nationwide has an objective of funding projects in DOE EPSCoR which are indistinguishable from projects funded across basic sciences in DOE. That is, they really expect the same level and quality of performance in the proposal and in the research. So that's an important metric to think about. So let me talk to you about this proposal that was put in last year. It was put together very quickly in a matter of several months. This was the first time that people were permitted to compete for a second implementation award while they were already operating one. And so we weren't expecting to have this opportunity, and it came along, and the group that put this together did very well. This was centered around the electrochemical energy storage and conversion technology, and it was using two of the research centers that we have in the state. One is the Center for Applied Energy Research. The other one is the Kahn Center for Renewable Energy and Resources at University of Louisville. It was a very nice collaboration. So what makes a great DOE EPSCoR proposal? Well, first of all, what I was going to do is talk a little bit about what was the submission and summarize the review criteria so you can see how these things are reviewed. Talk about strengths and weaknesses. Actually, I'm not going to talk about strengths. We had some tremendous strengths in this proposal. And, of course, the things that are going to differentiate you is how serious some of the weaknesses are. And then talk what would need to be tweaked if we were going to continue in this area again. What would we need to do to make this proposal jump out and get funded the next time? So first we need to talk about leadership and relevance to DOE. DOE has a number of strategic aims, and you do need to demonstrate relevance through your proposal in the subsections and where you're talking about each one of your specific projects. You do need to link that to some of the DOE programs and initiatives and needs. At the same time, you need to link that to the state research plan, which we have, which is great and will help us a lot in the future. The leadership for this was coming both from U of L, University of Kentucky, and Transylvania University in town here. It's relevant to DOE because they want to do topical research on batteries, electrochemical capacitor manufacturing as well. The specific office, and this is something you need to know for a DOE proposal, you need to know the specific program office, which is likely to be reviewing your program. And then you also need to know who the point of contact was. These implementation awards at DOE are 36 months, and roughly about $2 million per annum is a typical number. So that gives you an idea that this is supposed to be an integrated team, big science, but they also would like a very clear focus. So why is this important, and what was different about this particular proposal? The proposal really talked about a paradigm shift in battery and chemical capacitor manufacturing technology. If you know anything about battery manufacturing, you know that it is done at very high speed, what you can do on a manufacturing line is actually quite different from what you can do in the laboratory. And so coming up with innovations really has to be very closely linked into the technology of the process itself to make evolutionary changes. Revolutionary changes mean that you have to have good enough science to justify a completely new manufacturing process. So you need to look at both of those two things as you're trying to move the science and the technology forward. So this particular proposal was going to use an experimental process platform which was industrial scale to synthesize, design, and fabricate electrochemical storage materials, but then link that into fundamental nanoscale by design materials. We needed computational tools. We had to have a vertically integrated team, and we did need to have some links into the business. The approach was to link the, as I said, CAR and the battery manufacturing research with the Kahn Center for Renewable Energy Research. We need to have a prototype line for producing batteries and cells of commercial quality. And as I just said before, the novel materials, as great as they may be, need to integrate into a current manufacturing process, or you need to come up with a new manufacturing process that takes advantage of the novel science that you're able to do. So being able to quantify optimal conditions and having scalable systems is pretty critical. So here are the links to the national needs. These are kinds of things that would be up front in the proposal. We would link into the state need. There was a technology plan, which we knew we had a draft of, which was very important to us. There was a 2008 Kentucky Energy Plan that we could cite. NIST had given us an ARRA award for facility construction, and we had good links to the Kentucky Cabinet for Economic Development. At the national level, there have been documents written by DOE on the compelling need for electrical energy storage technology, and in particular with lithium-ion battery systems, particularly the materials processing, design, and system integration areas. So those needs were taken directly out of the studies done by DOE and placed forefront in the proposal as linking into what the national need was. And then finally, DOE EPSCoR would be interested in this itself because this would be a way to have faster, higher reliability cell assembly line operation. And so this would lower costs. This is the kind of thing that the Department of Energy is particularly interested in. So one of the things that you'd like to have in a DOE EPSCoR proposal is a unique facility. We had a unique building. We were proposing to put about $1 million worth of manufacturing line into the building so that the engineers who were running the line could talk directly with the scientists that were developing new materials and integrate those things seamlessly, or as seamlessly as possible. So the collaboration between the line team and the materials researcher was really critical to the success of this program. Here were the various program elements that were called out. We had an active materials synthesis program. We're going to do things like encapsulate electrode particles with thermal responsive polymers. A lot of these, the things on this list have to do with making the cathode or making the electrodes here and how they could be manufactured differently. The sixth item there is the novel catalyst synthesis for lithium air electrodes. That particular system is a little bit different than the rest of the systems, and as you'll see later, that was an interesting choice. So let's talk about how these are reviewed. At DOE, most of the review is going to be done by people in the national labs who are linked in to the technology area. So that's one of the things you need to understand going in. You know, your audience is people who are doing these kinds of work already at DOE. There are 6 areas. First one is science and technical merit. We all understand that. The next one is your approach appropriate? Next is, do you have a good team? Do you have adequate resources? Is the budget reasonable? Do you have synergy among the team? It's very good if folks have already been working together and collaborating, and you can demonstrate that through conference papers, publications, et cetera, and other proposals as well. Those are part of the metrics that you have to provide as you are awarded one of these projects, you have to show that over time. And then finally, the last criteria is sort of a thumbs up, thumbs down kind of thing. What's the likelihood of success? How would you be able to hire competitive faculty? Can you hire competitive and outstanding graduate students? What is your unique infrastructure that you're going to build to make yourself different? Do you expect to have sustained leadership in the field? And are you leveraging DOE funds with funds from other places? Okay, so what I'm going to do is we really scored very well in all those categories. I've just picked out places where people saw weaknesses. So you're not going to see too many strengths on this screen. But let me tell you, there were some tremendous strengths of this proposal. Remember, we were talking about the importance of linking in the manufacturing process to the research. This first little bullet it relates to that, and that we had a piece in there on 3D assembly, very inventive, excellent idea, and what they were really asking about and got a negative review was, okay, so you're going to do 3D assembly, how are you going to do that on the manufacturing line? You know, maybe we could answer that question, but we didn't help with that answer in the proposal. Another question which kept coming up consistently is scale up, and scale up. How are you going to take what you've done at the bench and put it into a line that's putting out a number of cells per hour? And then, along with that, what's your screening criteria for material selection? There were some elements in there, as you might think with batteries. There are some nasty things and things which are hazardous, and some are nastier than others. And so there were some practical questions about, you know, do you want to do this on a large scale? And then finally, remember I was talking about the lithium-air battery concept. This is a very important concept, but the reviewers particularly picked this out because they said everything else is focused on cells and batteries and more typical electrochemical storage. The lithium-air system is simply at the concept, let's go out and understand this stage, and links to manufacturing, which is what we propose to do, wouldn't exist for many years because we don't expect to make them soon. So we did have a great focus, but this particular element didn't fit as well in that focus as it might have, or we didn't explain it as well. Do we have an appropriate approach? We did very well in this category. There was one issue here, and that is several times reviewers suggested that we need more industrial participants because the knowledge of the materials and the manufacturing in a practical sense would be very, very helpful, along with helping with scale-up issues. And then here you see that nickel and cobalt were called off for safety issues as well. Do we have competent personnel? We got great praise on our personnel. What we did get dinged on a little bit were getting more researchers from industry and more young scientists with battery experience. A reasonable budget. Budget did very well, except remember you're being reviewed by a national lab, and somebody there was saying, gee, I'd like $1 million for a manufacturing line at wherever they were. And so they actually wanted to see somebody local put up that $1 million capital investment to do that line. And basically that's a perspective from the national lab, obviously. The team got great reviews. It was well integrated, and working with the national lab and the two universities went over very, very well. Likelihood of success. This really is the summary. We missed two sections in the proposal and had essentially no plan for faculty hires and specific graduate student recruitment. Those are easy things to do. That we didn't do that as well as we could have. We had a plain vanilla outreach program. They were looking for something a little bit better. And then the two issues that I talked about before, I think, were the major issues. Scale up and scaling up with industrial expertise and people who have run these kinds of things for a long time, and then the capital investment issue. So, what would be a path forward? This was really an excellent proposal. And I think with a tighter focus, little tighter focus, not much, but a little tighter focus on the work and more industrial involvement, this would be a winning proposal. And so I'd be happy to answer any questions. I hope the folks who worked hard on this don't mind. I thought they did a great job, and I think they're very, very close. And hope that this would be useful to you to see how DOE looks at proposals. Thank you very much.